So last time we talked about rectangular approximations, right? Method. RAM, is that what we abbreviated it, right? And then we had RRAM for the right side of the rectangle, LRAM for the left side, and then we had MRAM for the midpoint. Yeah? Now notice they were all rectangles and we were summing up all the areas to get the area underneath the curve. Yeah? The area underneath the curve can be approximated using Riemann rectangulars, which is this person right here. He came up with this technique. So I call it rectangular approximation. Most people call it Riemann sums. Riemann sums is just a fancy way of saying a bunch of rectangles added up together. Riemann was the guy who discovered this method, and that's why he gets it named after him. And I think it's worthy of it. Now here's the thing. You look at this equation, right, and it's like, what the heck are those, right? Now, remember, last time we did this, let me show you this before I move on here. I gave you this one right here. Let's look at this RRAM right here. Okay? Look at this RRAM. Yeah? We got 0.5 here, 0.5 here, 0.5 here, 0.5 here, 0.5 here, 0.5 here. They're all the same 0.5s, aren't they? And they were all the widths of your rectangles, weren't they? Yeah? That's all that's going on in this equation. This right here, this delta x represents your width. I can't spell. There you go. So those represents your width, right? And you're just multiplying it with, now this is the part that looks tricky, what the heck is this? You guys have seen this before. F of x is a notation of your function value, okay? So don't write this down like I said. You've seen this before. If I had f of x was equal to x squared, right? And I asked you, hey, what's f of 3? What would you tell me?
3 cubed.
3 squared times 9.
Yeah. So that right there, when we were plugging it into our other chart, we had t squared instead of x squared, right? And you were telling me that t squared was the height of the rectangle, right? That's what this part represents. Okay? When you multiply a height by its width, you end up calculating an area, right? And that's what this represents. It's the height times the width. Now this new thing over here that you haven't seen before, have you ever seen this symbol before?
Yes.
Yeah.
You have?
Yeah.
What's it called?
Tribe. I remember it was like in an equation last year in math, but
Yeah, it was in like the
The sum.
Yeah.
Sum.
yeah. Oh, okay.
Yes, this is the sum. This is the sum. By the way, the Greek name of it is sigma.
Sigma. There we go.
Sigma.
That's
Sigma.
not. Yeah.
But yes, sigma or S for sum, right? Sum means you're adding up a bunch of the same things, but different values for each one, right? So when we're doing the other way, the heights were changing every single time, right? And then we would just sum them all up. Does that make sense? So that's what this is. It's saying the sum of the first rectangle all the way up to the nth rectangle, and the n being whatever number of rectangles you want. So if you wanted 6 rectangles, it would be the first rectangle plus the second rectangle plus the third rectangle plus the fourth rectangle plus the fifth rectangle plus the sixth rectangle. Add it all up together. Ran out of breath.
can we write this down?
Oh, if you want to, yes.
Okay. Because I'm gonna forget this in like 2 seconds.
Okay. If you want to, yes.
I can see fish. It says don't copy.
I wouldn't, but
You're gonna forget it.
It's just the.
I forget things in general. That's true.
all right. I'll do this then. Just take that off and say, copy this. Would that help?
Yes.
Just that equation. Okay. All right.
Why does it look like that though? Like, what is the symbol like?
The summation. So the Greek letter is called sigma, and it's an abbreviation for our word sum. That's all it is.
No, I know, but like, what's is like the shape mean anything?
No, it's just a Greek letter. Just like our A actually comes from a Greek letter alpha. Our B comes from the Greek letter beta. Sigma, though, I don't think looks like an S, but
Just gonna like talk about
Greek letters?
fractals.
So this is how you find the area of a rectangular approximation like with RAM, like LRM and stuff. Oh.
Yeah.
Does that say k equals 1 at the bottom?
Yeah, K equals 1 right here.
And is that an a at the top?
That's an N.
What happened?
N?
Yeah, here. Just, is that?
Sorry.
Oh,
we were
yes,
like-
that's
Oh wow. Okay,
There.
yeah, that helps.
There you go.
I don't have my glasses today, so
Everybody forgets.
I don't have my glasses.
You know, but,
Oh,
but aren't
yeah.
but aren't both expensive?
Yeah. But contacts are more expensive.
Especially like they're less covered.
I'm so
feisty today, I'm sorry.
All right. So this is the equation, and I hate giving out equations because I think what we did last time on Friday made more sense. You were able to actually visually see it, right? But this equation is just the math part of it. Like, this is the explanation of what we were doing on Friday. We were taking all those rectangles and approximating each rectangle and then just summing them all up. The reason why I'm showing you this formula, though, is because if you change the number of rectangles, you're not changing your method. You're still doing the same thing, but you're just figuring out a different width for each one. And then you are still multiplying it by its height and then adding them all up to get your total area, right? So in calculus, we like to find an equation that represents the stuff that we do repeatedly. And this is one of those equations. Now, are you going to have to memorize this? Not really. I'm just trying to show you where this thing comes from, right? What you want to memorize is what we did last time, which was this step, okay? Getting each of these widths right here and getting each of these heights right here. So doing it for all 6, right? And then adding them all up, okay? Yes?
So to plug it into this equation, where it says f of x, k, is that like how many, is the k how many rectangles you make?
Oh, I'm so glad you asked that. The k is a specific value of x. So, so glad you said this. So if I was looking at this, right, this is x sub k, right? But k is going to go from 1 to, let's say, 6, okay? So what this is going to look like is, for what we did the other day, was f of x of the first rectangle multiplied by the width of the first rectangle, right? And then you would add that to f of x of the second rectangle
I see.
times the width of the second rectangle.
So you do that for each and every single term?
Yeah,
There's
rectangle.
no abbreviation that you can do? Or?
No, well, this is the abbreviation.
Oh, okay.
This is literally the shortcut of what I'm trying to say. So if you go back to our old notes, you ready? I'm sorry, I keep going back and forth, but check this out. Let me erase all of this right here. So this is the right rectangular approximation, yeah? I'm using the right side of my rectangle right here. So f of 0.5, right? That 0.5, that's your x value of your first rectangle. And then you multiply that by just the width of the first rectangle, delta x1, which is 0.5 because it's 0.5 from here to here. And then you're going to add that with f of 1. F of 1 because that's your x value of your second rectangle. See that? Multiplied by with its width. Its width is also 0.5. See that? Plus the third rectangle. See how this is number 3 right here? This is the third rectangle? It'll be f of 1.5 because 1.5 is the third x value. And you're working your way through. So k in this case is going to go from 1, 2, 3, 4, 5, 6. And that's what the k value is. The k value going through there is going from 1 for your first rectangle all the way up to the total number of rectangles you have. Does that answer that question? Okay, no problem. I'm glad that helped. So, I know, again, looks weird, right? This whole thing is like, what the heck is this? But don't overthink it. We already did it on Friday. This is just the notation part of it, okay? You've already done this. Don't worry about the notation. Now, we did LRAM, MRAM, and dyslexia. We did LRAM, RRAM, and MRAM right there, right? For the left-handed coordinate, the right-hand coordinate, and the midpoint of it. Now, just a quick refresher. How do we figure out how wide to make the widths of each of the problems?
Interval subtracted by 0 or something like that.
Yeah. And it's right here. If all the intervals are the same width, and there are 6 rectangles, what is the value of delta x sub k? And we got this yesterday, or Friday, right? Or Thursday. It was 0.5, right? Now, how do we get that 0.5? It's the distance for the interval. So what's the distance? We just subtract the end point from the beginning point, right? And then divide by the number of rectangles. Yes. So that's all we got to do to get that, right? Okay. As of right now, you already saw it's kind of annoying if we do 6 rectangles. Could you imagine if we had 8 rectangles?
Oh, yeah.
Right? That's already annoying, right? So what I'm going to teach you right now is, can you guys grab a TI calculator if you have one? And if not, borrow one of mine. And I'm going to show you how to shortcut it using the calculator. This is not a mandatory thing to do on the AP exam. This is just something I wanted to show you that's kind of neat as a tool to have.
You know, on the test when I did the graphing, I felt so proud of myself because I finally was able to graph a calculator without asking help.
That's good. That's good.
Like, yeah, I don't feel old anymore. I know not technology.
Does advertising like help you feel better?
Yeah, it does, especially if you're angry.
Loki knocked me out on graduation.
Graduating's overrated.
Graduation's overrated.
I don't know. I remember when I was a senior, and my ex at the time asked, like, are you excited that you're going to graduate? And I was like, no. It's kind of like that's what normally happens.
Do you still talk to anyone from high school?
Yeah, one of my best friends is from like 7th grade.
Oh, wow.
Is it true that you only have like 2 friends, 3 friends after high school?
Probably less.
That's for real?
Yeah.
Then two?
What's lesser than 1?
Yeah, you still actually outside
Zero.
school? Was it
Half.
make friends?
Whoa.
What's up?
Was outside school did you get make friends?
Yeah.
Yeah.
It's okay. So we'll talk about this later. Let's just focus back over here. Let's focus back over here. So let's say I was looking at this function right here. F of x is going to be equal to 9 minus x squared. Okay? 9 minus x squared, and we're looking for it on the interval from 0 to 3. Here's what that graph looks like right here. Okay? Now, if I'm doing LRAM with 6 rectangles, right, they broke it down into halves for us, 0.5 right here. So LRAM would be this rectangle right here, this rectangle right here, this rectangle right here. Oh, wait, no, that's wrong. That's RRAM. That's RRAM. Hold on. This rectangle right here, this rectangle right here, 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 and there. First of all, what do you notice about this approximation? Is this going to be an overestimate or an underestimate?
Overestimate.
Overestimate, which is interesting, isn't it? Last time we did LRAM, it was an underestimate.
Yeah.
But this time it's over. So, do you notice why?
Because of the graph.
Because it's decreasing.
Well, it wasn't it because it was a linear?
What was our graph last time?
It was going, it was in, yeah.
Like that.
It was a concave up.
It was concave up, and it was increasing.
Yeah.
So that gave us a underestimate. This is concave down, decreasing. Looks like it's giving us an overestimate, right? Now, if you ever need to figure out if something is going to be an overestimate or an underestimate, I think it's best if you kind of picture it, if it's increasing, decreasing, and if it's concave up and concave down. Because if you can see it, right, if you can see that it's concave down, you know that the left sides are going to go over, right? But if it's increasing concave up, you'll know that the left side is going what? Under, right? So you can figure out if it's an over approximation or an under approximation, okay? Now, let's do this real quick here. I haven't done this in a while, so I'm going to mess this up. So you're going to follow along with me and mess this up with me. Woo! Yay. All right. Let me double check here. How did I do this last time?
Great question.
Yeah, I have no idea. Cool. So here we go. Let's plug in our equation first of all. Where do I go to plug in my equation? So let's go to y equals. Let's plug in our equation. 9 minus x squared, right? Yes.
Right there.
Sorry, it's right there. Sorry, my fault. Yeah, it's all over. I'm all over the place. Maybe I should have printed this out.
You should have.
It's okay. Well, I did something.
But it's alright, there's no
Oh, never mind.
Right. Anita's the only one in school over here.
No,
Anita,
it's okay.
We could have like drawn on the graph.
All right.
Wait, hold on.
So I plugged it in, right? If you hit graph, you can kind of see the graph. There's this parabola right here. Now the window looks different, doesn't it? Why does their window look different?
Because it's taken over only on the decreasing side.
Yeah, it's only looking from what intervals?
0 to 3.
So how do we change the interval on this window? If
This button says window.
there's a button that says window. Very good. Try tapping on the button that says window.
Yeah. I did this during the test.
Now, when you tap on the window button, which is right here, there's a bunch of stuff that looks crazy. Yeah? I need to get you to practice this because Desmos, for some reason, is not going to be on the AP exam. You're going to have to use these calculators. Now, if you need to move your screen, you can move it manually, or you can type in the things that you want. My interval is not going from -10 to 10.
No.
It's going from 0 to 3.
Right.
But if you go from 0 to 3, it's going to cut it off, right?
Yeah.
So let's go a little bit past 3. Let's go to like 0 to what? 5? We can do that. You can also do 0 to 4. It's up to you. I'm going to go from 0 to 5, like you said. Now, here's the other thing. What are my values changing by?
0.5.
That's what the scale is.
Correct.
So instead of going by 1, I'm going to have to go by 0.5. Each tick mark that shows up on the calculator would be 0.5.
Yep.
Now, the y value is currently going from -10 to +10, right? It looks like we don't really care about the negative values. So let's have the y value go from 0 up to 10. Now, I'm just picking these numbers randomly. When you do this on your own, you can pick the numbers as random as you want. Go ahead.
How do you clear the random?
Oh, second, memory, the plus sign.
Wait, second, remember?
Yeah, hit second, then the plus sign.
Okay, second, then the plus sign. Oh,
Yeah, and reset it.
thank you.
All right, there we go. Beautiful, isn't it?
What about the express?
The what?
Wow, I did it.
Don't ask questions.
The express.
Yes, it's at the bottom of Y scale.
X or yes?
What button is this? Oh, in here?
Yeah, window.
The resolution. Don't worry about that. Don't worry about that. I got you. That was on this window. Yeah. So, anyways, there's the graph. Right? All right. So here's the thing. So if I'm going from 0 to 3, right? Do you know what my x coordinate values are for each of these rectangles? I have 6 rectangles here. Right? What are my x values on here for these intervals? 0.5, good. What's this one? 1,
1.5.
1.5. What's this one? 2. This one? 2.5. And what's this one? 3. I'm missing one.
3.5.
No.
0.
0. Good, good. I kind of need the 0 in this case, don't I? Because I'm looking at it on which side? The left side. And you see this first value right here? Is where the 0 is. You see that? So I'm going to be using 0, 0.5, 1, 1.5, 2, 2.5. Do I use 3? Not to get the height, yeah? Not if it's the left side, right? So here's what I'm going to do. We're going to go into the stats section, and we're going to plug in these values. Can you go with me to the stats sections here? There's a stat button. You see it?
Yeah, where?
A stat?
Stat.
It's
Right
DEL.
there. You see it? Underneath the delete button. Press the stat button. You got it?
Yeah.
When you press the stat button, you'll get this option right here. We're going to go in here and we're going to edit this table. So can you guys go ahead and press enter on edit, and you should get an empty list. Is your list empty? Okay? This is a table, and you're allowed to plug in numbers into this table. What we're going to do, though, is design L1 to be all the x coordinates for each of the rectangles. So what are my x values? 0, 0.5, 1, 1.5, 2, 2.5, and that's it, right? We're doing 6 rectangles. Can you type in those values? And by the way, once you type it in, so 0, just press enter, and it'll move you down automatically. 0.5 is the next one. 1, 1.5.
Do we end it at 3 or no?
We ended at 2.5. But we would end at 3 if we were doing the right side. And we also would not have a 0 if we were doing the right side.
Oh, yeah.
Oh, because it is at 0 at 3, right?
Wait,
So-
you ended up what, 2.5?
2.5.
Like, seriously? You know what I'm talking
So,
I said it fast.
so look. So these are the 6 values that I have from our rectangular thing right here, yeah? Here are my 6. 0, 0.5, 1, 1.5, 2, 2.5, yeah? So those are actually my widths, right? Not my widths. Those are my x values there with the same widths. Yeah, 0.5 all the way across. Okay. Now, we did this by hand the other day. I want to show you that you can actually calculate all of these heights using the calculator. You ready? So these are all the x values that I want to give me the heights at. And again, I'm supposed to plug them into this function right here, right? So for example, if I wanted this height right here, I would plug in 0 in for x, right? So this would be f of 0, and f of 0 is going to be equal to 9 minus 0 squared, which is just equal to 9. So this has a height of 9, right? That's not that bad, yeah? But check this out. I'd have to do it again for 0.5, wouldn't I? What's f of 0.5? Well, that's going to be 9 minus 0.5 squared, and then whatever the heck that is, right? Which will be 9 minus, which comes out to 8.75. Again, not that bad. But when you do this for multiple squares, you start to go a little crazy, right? So check this out. The TI calculator can do it for all of these numbers for you. You just have to command it to do so. Now, this is the part that's going to be hard, so hopefully you're paying attention. I'm going to put the numbers into L2. But in order for me to fill out all of these, I have to put in a direction for it. And the place you put directions for it is going to be at the top where L2 is. So can you guys make sure your cursor goes over to under L2 right here? And then push the up button so that your cursor highlights L2. All right, you got it highlighting L2? All right. Now, with it highlighting L2, we're going to type in an equation. The equation we're going to type in is this one right here. 9 minus, now pause here for a second. Don't push x. Because if you push x, it's going to be like, yo, what's x? It doesn't know. And then you have to type it in one at a time. We already stored our x's. Where are our x's stored?
Oh, L1.
So here's the thing. Here's the thing. Do you know how to get to L1?
No.
Does anyone see the L1 button on your calculator? You see it's in blue?
Yes.
Right there above the 1? So push second and then 1.
Then square.
Then we are going to square it. So push the square. Now pause for a second. What is this going to do? It's going to go take 9 and then subtract from it every number that's in L1 after it gets squared.
Oh.
After you type that in, press enter.
Oh my god,
Wow.
yeah, that's cool.
So I didn't do all of them, but I'm proving that the first two work, yeah?
Yeah.
The first one was 9, and we got 9. Yeah, we did by hand. The second one we did by hand, we got by hand. The second one we did by hand, and what do we get here?
8.75.
And that's what they have here. Okay?
She's laughing.
So we got all of those values. Now, why do I care about those values in L2? Well, also, aren't they the height of the rectangles?
Yeah.
This 8.75 is the height of the second rectangle. This 9 is the height of the first rectangle. Guess what these are? It's of the rest of the rectangles. Yeah. So now I got this height, 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 I got this height. Each one of these needs to be multiplied by our width. Right? Because they all have the same widths, don't they? What are the widths? So let's put those widths into L3. Can you guys do that with me? 0.5 and put it for all 6 of them. 0.5, 0.5, 0.5.
Wait, for the third spot?
Yep, for the third slot.
0.5?
Yep, 0.5s. Why 0.5s? Because that's your width. Edit. Each time you push 0.5, press enter, yeah. So, do you have a 0.5 for all of them?
Yes.
Each of those 0.5s represents each of the widths for each of the rectangles, yeah? The first 0.5 is the first width. The 6.5 is for the sixth rectangle, right? So in this case, they're all the same widths, yeah? Now, what are you supposed to do with the height of your rectangle and the width of your rectangle to get the area of a rectangle? So, it looks like we're out of lists, aren't we?
We still have more.
Ah, push to the right. You have an L4.
We still have
Yeah, there's like 6 of them in total. I'm just messing with you. So, Now, let's see again, if you remember. How do I tell it a command to do it for all 6 of them? So, can you go do that real quick? Let's highlight L4,
Okay.
and we're going to give it directions.
Second.
Second. We don't want L1 anymore.
We do four. We do
Oh,
four.
two.
Oh, wait, two.
L2, because that's where we stored all the heights. And what are we going to do with those numbers?
Multiply them by L3.
Multiply them by L3.
Oh, I messed up.
So when you take L2 and multiply by L3,
You get numbers.
you'll get all the heights.
I get
Wait, did I mess up?
That is cool.
L2 times L3.
Oh. L3?
L2 times L3.
Okay.
Oh, so now moving back here, this is the height. No,
Oh.
This is the area of the first rectangle,
Yeah.
which makes sense because it has a height of 9 and has a base of 0.5. If you do 9 times 0.5, you get 4.5, which the calculator finds for you.
yeah, I had it.
Now, I have this height right here, this base right here, this area calculated. It's done for all 6 of them, isn't it?
Yeah.
Now, as amazing as this is, it's still annoying to write down all 6 numbers and then add them all up. I mean, it's like, that's cool. I didn't have to do the multiplication. I had to do the square. I got these numbers. But let's get even lazier. I don't want to sit there and add these all up. That's still a pain. Can you imagine? You need a second calculator or you need to write down all the numbers. And if you could imagine, what if you had like 10 rectangles?
L5.
Is
Yeah.
there any way to add like
Yes. Now to add them, we don't add them into L5 because they're doing it for each of the slots. I want to add everything in L4. Yeah? So this is the last step. All these numbers are stored in your calculator now, by the way. If you turn off the calculator, you turn it back on, these numbers are still there. Which is kind of nice. But here's what we're going to do. I want to do some math using all this. So we're going to go ahead and press second and then mode. And what that does is it takes you back to the home screen. So remember, all that hard work is still there. All those numbers are stored. We got the heights, we got the widths. But on the home screen is where we get to do the calculations for each of those lists. I want all the numbers summed up after we calculated the area. Yeah? So I'm going to look for an operation that's called the sum. You ready for this? So if you press second list, or stats, I'm sorry, second stat, this is the names of all the lists. You see them? We got L1, L2, L3, L4, L5, L6, yeah? We're going to go to math. So can you push the right arrow on the top? Go all the way to the right, and you'll see there are operations that we can do for our lists. One of them that I care for is the sum. If you guys ever decide to take statistics, this is how you find things like the standard deviation, if you decide to take statistics. If you took it at an IM1, you also should have did this. Yeah. Anyways, let's go ahead and find the sum, right? Press enter. It'll take you to here. Where were all our numbers stored? So you could go back to the list, or we could just hit second, 4. So what's that going to do?
It's gonna add up all the
It's going
numbers.
to sum up all the numbers in L4. That's right. That's right. So go ahead and press enter.
Oh, that's Liddy.
So what's my answer?
So is that the cumulative
Wait, you guys got 20.
area?
That is the cumulative area. Yes. Yes. 20.125.
Should we close a parenthesis?
43.25.
Say it one more time.
Can we close a parenthesis?
You can. You can. 20.125. You okay? Does it make sense?
Yeah.
Does it not make sense?
Not to AJ. Not to AJ. AJ got 43.
It's okay. That could be a calculation error somewhere in the list. So here, AJ, let's double check your list values. So you open up your list already?
How do we do that?
Stat,
That.
edit. All right, let's go through it one at a time. What do you have for L1? 0, 0.5, 1, 1.5, 2, and 2.5.
0, 0, 5.
Yes.
Yeah, no. No, he's saying 0.5, I'm assuming. Right? Or no?
Yeah,
You have 0 twice?
I have 0, 0.5,
1,
1,
1.5.
1.5, 2, 2.5,
Perfect. So that's good. Let's go to L2.
9,
Uh-huh.
8.75,
Uh-huh.
8,
Uh-huh.
6.75,
Uh-huh.
5,
Uh-huh.
2.75,
Good. L3. Good. What do you got for L4?
9.5, 9.25.
Okay. So, hover up to the top of L4, and we're going to do this together. So, if this ever happens, like, and you need to delete it, please don't hit delete.
Why?
It deletes the L4. It doesn't delete the contents of L4. So when you delete it, when you press the delete button, I'll just show you. Don't press it though, but just watch. So what happens if you hit delete?
You delete everything.
L4 is gone. So you see how it goes from L3 to L5? Very annoying.
What?
So if that ever happens, you have to hit second insert to insert the list, and then you have to tell it, hey, bring back L4. And it didn't actually clear out the numbers. You see that?
Wow.
Yeah, I just deleted the list off the thing, and then you bring it back. It's still there. So what I need you to do right now, AJ, is highlight L4, because those numbers are wrong. Press clear. Not delete, press clear. You got clear? And then press enter.
Yeah, me too.
Enter?
Did it clear all the numbers out, but
Yeah.
kept L4 there?
Yeah.
So we're going to try this again. All right? L4 is going to be the area of the rectangle. The area of the rectangle is base times height. So we're going to multiply L2 times L3. Okay? So how do you do that? Highlight where to tell it the directions.
L4, and
Good?
then we go second,
Uh-huh.
second 2, right?
No, yeah.
Yeah, second 2, right?
Uh-huh. And then multiply.
Times second 3, right?
Good. Press enter.
Oh,
Now you got it?
4.5, 4.375.
Good. So that right there now represents all of the areas of each of the rectangles. Then we did the sum and we summed them all up. Okay? So how do you get out of this? Second quit, and you get out of there. Here's what I want you to try. Same equation, 9 minus x squared, yeah? But I want you to try it with the right side for me. Try it with the right side for me. So here's the thing. So if we're doing it on the right side, yeah? If you do it on the right side, you're not going to be starting at 0. Yeah, because if you write it out, it's 0, 0.5, 1, 1.5, 2, 2.5, and then 3. Yeah?
I'm gonna add the 3, take away the 0.
But if we were going to do the right side, it's going to go this way, isn't it? Like this.
So we put clear?
You can. To delete the list. Yeah?
It's gonna be underfed.
Oh,
How do you go
yeah.
back to the list?
So, let's do it together. Or actually, no, you guys got it.
Wait,
But
how do you go back to the list?
stat, edit.
Right, okay.
Now, so your L2 are no longer valid. Your L3 is though, isn't it? Your L3 should still be 0.5s because
L1
you
isn't
notice.
valid either.
And L1 is invalid as well. It's actually not the
Starting
same.
at 0.
It doesn't start at 0 this time,
I
does
mean,
it?
it starts at 0, 0.5, that's what I mean.
Yeah, and where do you end?
So we have to clear
Three.
out L1, L2, and L4?
We'll do it one at a time. Just fix L1 right now. Get it to look correct.
The what? Oh, thank you.
You look strange. Good job.
Sure.
Kind of.
Should I send him with the stuff?
How does that look?
What does that mean?
I know, I just fucking with
Why
you.
don't
I know.
Devin, you gotta go see Miss Bernstein.
Yep, alright.
Bye there.
Hey, Jasmine.
What?
Take good notes, please.
Wait a minute, so
Have fun, Devin.
technically L2 should be valid if you change L1, right? Because it should update.
I don't know. Try it.
Well, it was too late, I already cleared it.
So-
Have you cleared
I'm
L2?
tired.
No.
Okay, does it update the
Making me not
numbers?
want to go anymore.
What was the numbers beforehand? No, it doesn't. It stays the same.
Oh, it stays
Yeah, so you're gonna have to type it manually.
Okay.
So, wait, for the it's O1 third, right? Wait, what is it?
9 minus x
What?
squared minus 9 minus L1.
What am I doing?
My 3 is flat because the right side is right here.
Wait, wait. Oh.
Oh, this is it.
This is 3, this is 2.5, this is 2, 1.5, 1, and then 0.5.
Oh wait, the values
That's
are
for
same except for
MRAM. They won't touch it.
I think maybe it did update, but since the values are all the same
No, it
except for
changes.
0,
It
it
changes.
It's changing. Because, look.
just by a couple though.
Yeah.
Or 2. Or 1.
Kind of important. But,
Yeah.
so, did you guys figure out a shortcut for this, by the way, if you need to do this?
Yeah,
You-
I mean, I just redid everything you did us, and like I finished.
Oh, that works too. Yeah, yeah. I was gonna say though.
Right?
I was gonna say though, if I'm taking out the 0, this is where I can press delete. If you press clear, it kind of like doesn't really work too well. But if you press delete, see how it deletes it off your list. And then down here, I'm just adding the number what? 3. So I have 0.5 all the way to 3. Yeah, for the right side. But notice it does not. No, it didn't update it. So it does not update the values for L2. Yeah. So we have to go into L2 and update this. So we're going to highlight up at the very top. We're going to not press delete. What are we going to press? You couldn't press enter?
You could just press the number 9 and it'll delete everything. Not everything.
Oh, I've been pressing clear this whole time.
No, you don't have to. You
Wow.
just have to press the number that you want.
So
I press.
Or you can press enter.
9, yeah, 9 minus what?
Minus L1.
Good. Now this is the part that gets confusing, right? It's like we're so used to typing in x because the function is 9 minus x squared, but you have to tell the calculator where you're getting your x values from, yeah? And we're getting the x values from L1. L1 squared, where are you squared?
Up here.
There you are, press enter and it updates it for all of them. And Anita, does it make sense now why my line down here is flat?
Yeah.
Because it has a
Zero.
height of 0 there.
You guys got.
Are all the calculators like the same like structure, like the same buttons?
All the TI calculators are.
Oh yeah, that's what I meant.
Yeah. If you get a TI, they're all pretty much the same.
Oh, is that your back?
No, that's my leg. On
Oh.
the other side.
Oh,
Okay.
oh
All right.
my God.
Sorry, but
What
Yeah.
value, what
How
sound
come
did it
there's
get?
no, doesn't have like R or M? Why does it have to be L? Like on the calculator.
list.
Wait, how do you go back to the?
I have no idea. Like other than that.
Should've made it like R.
Do we need to change the L3 values?
Yes.
Yeah.
No. Do
No,
you?
no.
The widths are all the same in this case, yeah?
A stat for the list.
It's just on
It's the
L4,
same one.
you multiply again, you read it like L2 times over.
So we got to go to L4 and redo that one. And you're saying all I have to do is press enter and just start typing?
No.
L2? Look at that.
Yeah. Wait, what? Wait, what are you
It's
reading?
so
Yo,
cool.
I don't even know what's
But
happening.
I'm probably gonna forget it by next class.
Okay, so I'm just clearing out my L4. So don't overthink this, AJ. We're just doing the same we did earlier. All that I changed now is the L1 values, right? Because I'm looking at the right side of the rectangle to get my height. So I'm getting all the right values of my x values. So L1, AJ starts from 0.5 now instead of starting at 0.
And for your L2 values, you did get 8.75.
8.
8. Okay, yeah.
Yeah, yeah. So I recalculated it again and I got these new values, including the new 0 down here because at 3, the function value is 0. Okay? Then I kept everything in L3 the same because of the same widths in this case. Yeah? All the same widths. L4 is now going to be the area of each one, and how do we do that?
Multiply.
Yeah, but where do you set it?
To the L.
To the L4. What's up?
Are all the widths gonna be the same like every?
No. No.
Oh.
They will be different. Sometimes they'll be the same. I like it when they're the same. They make it so much nicer in unison. But sometimes they'll be different. Well, okay, so we're going to go up to L4 and multiply L2 times L3 to get my new volume for each of these rectangles. And they look smaller, don't they?
Yeah.
Which kind of makes sense because they're all what?
Underestimate.
Underestimates. Yeah? So, I got those values. How do I sum everything up in L4?
You go to
Second, mode, and you quit. Yeah, I started saying second quit, but then I realized not everybody knows where the quit is. So second quit, come out to the home screen. How do I get to the sum operation? This is a
Stat or list.
second stat, math, sum. That's a lot to memorize.
How come mine just stays?
If we do enough problems, I think.
And then we do
it'll stay.
L4.
Oh,
You-
right.
you-
Okay.
So
Do second 4.
second, 4. So we want to sum it all up. And what do I get?
15.65.
16 point, wait, what?
15.65.
15.625.
Are we supposed to be writing this down?
No, just practice. Just practice. You don't have to write it down.
But what if we don't remember?
You can. You can write down the steps if you want to.
Yeah. What are the steps? Can you go through the whole lesson again?
They're right here. There's only 4 steps.
How much say what?
5 steps. L1 is where your
Oh.
x coordinate is for each rectangle. So if you're doing the left side, you're going to get the left side of the rectangles,
Oh, cool.
right? The L2 is going to be the y values of each of those rectangles, which is basically the function, right? Plugging in the function and telling it, hey, use the numbers from L1. L3 is the width of the interval, and they should either all be the same or they'll all be some set value that you need to figure out. L4 is the area of the rectangle using the formula of L2 times L3. Okay? So those are all the steps. You fill out L4, and let's say you don't remember how to get to the sum stuff, then you can just write them down and sum them up on your own. The neat thing about these TI calculators is, let's say you don't know where the sum button is, like that sum right there. You could try looking for it in the catalog, and this is the part that's kind of annoying. If you hit second, 0, this is the list of all the functions that are on this calculator.
Wow.
And if you sit down and actually tapped on this and went all the way down to S, it'll take you a good minute or two, but it'll eventually get there. So how's your weekend? Everything good? Yeah, it's not bad?
Yeah, work was pretty fun.
Work was pretty fun?
Yeah, some dude, and I'm gonna specify race. Some black dude came in. You know what
Never.
I'm and he was all like, "You're Mexican, I'm black, bro." And they just started going off of my coworker, and I was all like,
Huh.
"On Black History Month?" Damn.
All right, that's annoying.
Yeah.
Oh, look. Sum. There's also summation, but it's the same thing. But we got it, right? Now, here's the thing, though. There's got to be an easier way, and there is. If I hit second, 0, and I go back to catalog, do you guys see how there's green letters? You see how there's A, or yeah. Yeah, don't hit alpha, though. But check this out. You see where the S button is? It's over the LN. Guess what happens when I press this LN button?
It goes to the S section.
Yeah, sample. So no, it does not explode. But yeah, so then it takes you right to S, and then you can scroll to the one that you need, which is sum. You see it? So if you know the name of the function, you can go to catalog and just type the letter that starts off with it, and then just scroll through there to see it. Yes. What's up?
Is the only way you can find sum during your calculator, or is sum just like actually adding everything?
Say that one more time. Is sum?
Is sum just adding everything up, or is it a specific wait, never mind.
No,
It
it's
is
just
a
adding everything up. Like,
It,
Yeah.
yeah, it's just adding everything in the list. It's just adding everything in the list for you. All right.
I got lost so many times, like, oh, do I press stat first? Do I press second first? I give up.
How about now? Are you okay now?
Yeah.
Okay, that's all that important. You struggled through it to get to the point where you're okay. And as long as you're okay now, that's all that matters. We accept the struggles. Okay? Why? There's already people who did it already.
There's games in here?
Yeah, but I didn't put it in there. All right. So, yes?
How do you get back to your list?
Stat, edit.
Oh, okay.
Stat, edit. All right, here's what I want you to do. I want you to try this, but for this function right here. Huh? We can. Do you want to do mid? No, actually, no, let's not do mid for right now. Can you guys do L and R for this function right here? It says for you to sketch it, but I'm okay if you don't. Keep it.
Step 1, understand the problem.
And then we'll have it for your example later. Say it one more time.
The 8 is the amount of rectangles.
Yes, very good. This is going to have 8 rectangles, and we're going to do it for L, R, and if you have time, do it for M. It says to sketch it, but you don't need to, but I'll sketch it for you.
We write this down?
Yeah. Just this part right here, for example, too. And we're going to go ahead and here's how the sketch looks like. You ready? 3 to the x power. We're going to graph this from -1 to 3. So if I hit graph right now, it's like from 0 to some number. So I'm going to go to my window and adjust it. Adjust it from -1. Let's go from -1 to what value? Let's go a little past -1. What's past -1? You okay if I go to like -2? Yeah. And then instead of going to 3, let's go to like 5 is all right.
Yeah, 5 is just there already.
Now here's the thing, my x scale. I don't know what my x scale is. How do I calculate my x scale? How many rectangles and... So, how do I calculate my intervals?
3 divided by 8.
Close.
It's 3
minus
minus -1
Oh, -1.
over 8.
Why is it 3 minus -1?
The 1.
Yeah, this is how far it's going, yeah? So what does that equal to? 4 over, which is? Oh, hey, that works out, doesn't it? what do you want our y values to be? Let's keep it at 0 to 10 just to see how it looks like, and if we need to, we can adjust along the way. Let's go ahead and hit the graph, and here's what the sketch looks like.
When you put the scale to 0.5, right?
Yes.
0, 0.
So maybe 2 to 5 is a little too far. Let's go from 2 to
3x?
2 to 4.
3
2 to 4.
the x power?
3 to the x power, yes. There you go.
So 4? Wait, what?
Would you put it on?
I put it to 4, but it's still kind of like kind of
0
big.
to 10?
What's up? The y value I went to 10. I think it might go higher,
So.
but
Is that 5 or are we going to
Wait, okay. I
For
need
the x minimum, you put -2?
Yeah, I'll just.
I put -2, yeah. You can put whatever values you want, though.
Yeah, but I want him to look like yours.
Oh. Get used to changing it around. Don't be set on just one thing, right? So technically, if I really wanted to, it should have been like this, right? Technically, it's from -1 to 3, but I went a little bit further behind and further ahead just so I can see what's happening around it. And then here's the y values. It's going from 0 to 10. If I knew that there were negative values, I would have the y minimum go in the negative so I can see what the graph is, right? But since it's exponential, it never goes negative. It just gets really close to 0. By the way, what's happening at the end point over here? What is it reaching? It'll be 3 to the what power at the very end here? 3 to the x, but what's the x being replaced with at the very end? So what's 3 to the third?
27.
The highest thing this thing is going to go to is 27. That's why when I graphed it, it was off my charts. So if you wanted to, you could put it up to what? 28, 30, right? Whatever numbers you want.
What about for your y minimum?
I'd put 0 because it never goes under. At least it doesn't look like it's going under.
And then y max 30.
Yeah, so yeah, that's that adjustment. I can go back to 10. It doesn't really matter which one you pick, okay? Just know that that's what it's going to, oh, God. Yeah, so we do that, hit the graph, you can't see it. What's up?
Mine, every time you like press something, like it does it says like negative 2.
Push, go back, go to, hit go to.
Oh. So we just
Are you hitting negative or are you hitting minus? Because that's the negative.
Oh.
No, it's just an old calculator. You can't tell the difference between negative and minus.
This is an old calculator?
Yeah.
Oh,
Like they haven't updated this. Like Desmos will know between a -4 and a -4. This calculator does not know the difference between a -4 and a -4. So that's why when you were hitting this button as your minus sign, not your negative sign, it was like,
Yeah, so I'm starting getting used to that.
yeah, it's weird. But yeah, so that's the graph.
After we do the graphing, that's when we go to the list thing.
Yep. So sketch your graph, right? So this is what the graph should look like.
Math.
Something like this, right?
Wait, how do we do the graph again? I'm sorry.
Hold on, I got you. But let me do this first. So this is 1, and it goes all the way to 3, right? And there's a total of 8 rectangles, so they got to go by 0.5. So -1, -0.5, 0, 0.5, 1, 1.5, 2, 2.5. So these are my rectangles right here.
I know.
Well, I mean, I've been doing this for quite a while. So those are the 8 rectangles. Don't worry about sketching the RRAM and the LRAM just yet. Just those are the. How did I? Your question, Jasmine, was how did I graph it?
No, how do you go to your list?
Ah, how do I go to my list?
Stat edit.
Stat, edit.
Ah.
So I'm gonna need to clear out some of these values, huh? So L1, I go to the top. I guess you could just press enter and start typing in. No, don't do that. Just press clear, I believe.
Yeah.
Just press clear and then press enter. Clear and then enter, I think, is the easiest way if you're gonna just start typing in things individually.
Clear than enter.
Yeah, clear then enter
What?
for L1.
Or you can just do
highlight
clear and like
L1.
arrow down.
Yeah, clear and
Highlight
enter.
L1, press clear, enter. It'll
Yeah. Now, did you get down your x values?
It's -1, -0.5, 0, 1.
No.
No, 0.5.
Uh-huh.
1.
Uh-huh.
1.5.
Uh-huh.
2.
Uh-huh.
2.5.
Uh-huh.
Since it's in the 3, so it's left. So we're gonna stop at 2.5.
Yeah, I'm sorry, these are terribly written.
So will it always be every value except the highest value then?
For the LRAM,
For
yes.
the right, and then the right will be
The right one will be every value except the smallest one. You're catching on. MRAM will be every value that's in between. Bro, my thing is bugging. So
Yawning, I'm just very tired.
I take offense.
You're not boring, I'm just very tired.
So
Kind of.
Anita,
I'm sorry.
don't try to memorize those rules. Like honestly, like okay, it's just all these except the first one, or it's all these except the last one. I think what works out. Well, actually, you know what? Maybe it works out better for you. You should memorize it that way, but I think it's easier if you draw all the lines out based off of these intervals. How did I know, by the way, that it goes from -1 to 3? That's the interval they told us. So I drew those first, here and here.
It looks right.
And then I just kind of marked out the tick marks based off of these this width.
Yeah.
So I just started counting. Okay, 0.5 of that would be -0.5, right? So -1, -0.5, 0, 1, 0.5. What is Jasmine? We learn together. We learn together.
Yes.
0.5, 1,
Yeah.
1.5, 2, 2.5, and then 3. Okay? Do you see the 8 rectangles?
Yeah, I do.
I haven't made which one's the top yet. We make that based off of if we're going on the left side or if we're going on the right side. If you're going on the left side, you just literally look at the left line and then draw your stuff out. So here's how left would look like. Left would go from here, and then I just draw my line to this way from here, from the left side. So this would be 1. This would be another one, another one, another one, like that. Does that make sense?
Yeah.
You see how I don't use 3? Because that's what the left side does. Yeah. Can you see the can you see the right one?
Yeah, I can.
You do?
I just figure out how to do that one.
It would be these, wouldn't it?
Yeah, but then it would include it. Just
Yeah, which one would it not include?
what is the last one?
Which is?
-1.
Yeah. So for the L side, it would be 0. I'm sorry, not 0. -1, -0.5, negative whatever. So yeah, get those values. See if you can calculate them.
For L8, I got 18.21. Yeah.
Is that what everybody got?
Yeah.
Well, so don't shout out. Just write it out. See what you get. If you got it, try the R8 next. See what you get for that one. Don't shout it out. Just write down your answer. See what you get. And if you finish that one and you feel confident enough, try the M RAM. Okay? Try the M RAM. You get used to it. You get used to it.
Oh, right. Okay.
What'd you get? I got 18.21.
Okay, I'm good.
So
How did I get there?
my first period class was having trouble how to student today. Like they were having trouble how to be students. And at the same time they were having trouble how to be students, I was having trouble how to be a teacher. I don't know why. Today's felt weird first period. Like I was struggling to be a teacher.
How do you still think? What does that mean?
I didn't want to teach.
Explaining your thoughts.
I just wanted to not teach.
Oh,
so you're just lazy.
No. I enjoy teaching. I just couldn't get into the mindset of teaching.
Wait.
Yeah. Wait, what? Oh, I thought you were saying today sarcastically, like as I do it all the time. No, yeah, today I was. I was a little hurt. I was like, oh God. But yeah, no, just today. Negative 0.5.
I lost my place.
See, sometimes I look at my history teacher and I'm like,
You don't
how
have
do
to
you
go in the
I'm
order.
like,
You
all the time.
can technically go 3, 2.5,
right one.
2,
Like,
1.5.
Why
You go
do I
back
do
to
this to
student.
myself?
So much. I lose the play.
Some people like
For the left one, is it?
because
no, for the right one.
you're
No, for the left one.
Left one, 18.21.
One of these days you gotta just make me a sandwich.
Wait, what? Let me see.
What
Cause
are
I
they?
can
Bucky
just
bread.
And
And then I was like, because they were so soft, and I touched them, and I was like, but then when I ate them, they weren't really.
Let me see, cause I did something wrong apparently.
What I do? What I do?
Well, you want to bring our
For the left one, I deleted it. I'm on the right
It's
one.
making
Yeah,
sense.
but okay.
It takes me like 30
Okay, I
minutes
don't know
to
what
make
I
this.
Oh, you're doing good.
Yeah. No,
So
but
you're all washing my food on
Write
the
down the
side and
answers
making
for
my
it.
breakfast.
Yeah.
Lunch,
Just getting used to
lunch.
that.
Woo.
No.
How you doing? Are you struggling or?
I lost my place. I
And we lost answer for the rest of the
thingy.
unit.
To the list. Right? Oh.
Sorry.
Compare your answers to each other. Okay? What did you get?
calculator.
No,
Like,
I hate
No.
tomato. I hate tomato too.
Me too.
Tomatoes
Tomatoes just
so
weird.
slow. Yeah, I felt
What
weird.
are the
So for
X
calculator,
interval?
No, I
It keeps
one
telling me
little
there's
kid
a
at
width.
Costco eat a tomato whole.
No.
I was like, that's disgusting.
It keeps telling me
You
there's
know
a
how we're always doing it in class?
You see that calculation over there?
Yeah.
That's what
That's
it
our
is.
widths. The 0.5.
My AirPods!
It has like things for opposite width.
Mitchell, she found them.
I know. It's
Oh, fancy.
See, I don't know.
No, I was just saying that mine are right here, so I know they weren't.
Because you're cutting it in
I don't know. That's why I'm like, I don't know what it is.
Alright, so yeah,
Oh, I think it does. Oh, because you're using
Okay.
Alright.
Oh wait, actually we're doing R8 too?
Yes.
Oh shit.
No, wait, wait. Are you recording? It's because you.
The midpoints. What's in between negative 1 and negative 0.5? What's between $1 and 50 cents?
How do you go out of this?
Yeah, so those are the midpoints you're going to put in for L1.
You don't have enough point
So you got to go between each one and calculate the midpoints. Which
Yeah, but how do you get
Honestly,
Wait,
I
for
don't
the
use
median
this.
one, the middle, you do
First one.
0.25
Next one.
because
What's
you cut
between
the
negative
interval in
50
half
and
if you
0?
think the middle.
Okay.
Just wanted to try to.
50 cents and 0 cents.
Thank you, Wesley.
It did something.
Will be the second one.
Yeah.
The third one would be 0 and 0.5. What's
I
between
realized
0
that
and
I'm an
0.5?
idiot.
Positive.
Then point to line, you know, from here.
Yep, go back to there, go back to L1.
Yay.
Change all
Stop,
those values,
boy.
and redo it again.
I'm over here like trying to remember it, but it just takes long because I'm like trying to remember how to do everything. So wait, wait. Oh, equation.
I need visuals.
You like
Then we go over to C.
Oh yeah, yeah, yeah. I'm good.
I'm walking my way around.
I didn't get the X.
Oh, pretty.
No, doesn't it go back to zero?
Are you guys gonna have like another answer? What the hell am I doing?
I don't believe
No,
I don't think so.
L4 is your areas now. So L2 is your height, L3 is your width.
Oh, okay, I got it. I need to grab this. Ross, we do have water.
No, I did.
So those are your areas for each of the rectangles.
Do you need us to do it in it too?
If you feel confident.
No.
Wait, what did you do?
I'm reading it right now. For the first L1? Yeah.
Yay! Come by.
No, we're all
Come
areas
by.
split.
You don't know how to do it?
I understood what you said. I just like
It was understandable, but.
So, as a class, what did you guys get for L8? 18.213?
Or 4.
Is there more numbers after that 3?
Yeah.
Give me all of them.
6, 7, 205.
Thank you.
Oh, you want to convert all of it?
No.
M state 0.5.
Say L3. In this case, yeah, L3 stays 0.5 for all 3 of them.
Okay.
Because the width doesn't change. They're just changing on where the height is going to be measured. Now, important thing. When you're doing these approximations, how many decimal places should you go to?
2 and round or 3?
2 and round or 3. If you do 2 and cut it off, you still get it right. Most of the times in Calc. In physics, chemistry, you care about significant figures, so you actually care about rounding it correctly, and because they do these things called margin of errors. In calculus, they're not pushing that as hard. So if you get this on your calculator, the more numbers you write down, the safer you'll be, but honestly, they don't really deduct if you cut it off. Now, if you wrote down 18, yeah, they're gonna get a little bit angry about that. If you wrote down 18.2, that's a little bit better. If you wrote down 18.21 or 2.3 or 2.13, I should say, there's not a real like penalty on those things. If you decide to, the word is truncate and you cut it off, they'll take that as well. So a lot of conversation just to tell you like, it's okay either way. Just pay attention to the directions that they tell you. If they want 3 decimals, they'll say it. If they don't want 3 decimals, you can go to 3 decimals and you won't be punished if you do that. Okay? All right, as a class, what do you guys get for R8?
31.54. Oh, we have it.
700. No. I just made this long conversation. You can stop here or here. You know, you can stop anywhere. You could stop at the 31.5. Okay, easy enough? Yeah. Did you get the M8?
No, don't say it. Don't say it. Don't say it.
Yeah, we're gonna say it just because we're gonna move on.
Okay,
I know.
23.97.
23.97.
And then like, and then you do the same thing, but just okay. I get it.
9705.
So how do we get the 23.97?
You're supposed to add like you're supposed to like you'll do negative 0.5 and then negative 0.25 and then so on.
Can we go to the table?
7.5, yeah, and 25.
Whatever's in the middle.
Yes. So for your x values, it's not going to be -1. It's not going to be negative 0.5. It's going to be the midpoint between them. And the midpoint between -1 and negative 0.5? Good. Next one after that will be between negative 0.5 and 0.
Negative 0.25.
Good.
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 Then it's 0.25. Then it's 0.75. Then 1.25. Then 1.
You see a pattern yet?
Then 2.25.
It's going up by I think it's 75.
I have to write it off for the visual.
It goes up by 0.25.
By 0.5.
0.5.
Can you move the calculator a little bit, please? Thank you.
2.25.
And then 2.27.
2.75, not 2.275. Whoa.
Wait, I feel like.
Did you get these values, 2.25 and 2.75? Okay. I was worried there because I heard you say 2.275.
Oh no, 2.25 and then 2.75.
All right, there you go. Okay,
I
so
think I did say 2.27.
Oh,
so
0.25.
are you okay with how I got these values? I'm just going between each of these x values, right? That's what midpoint is. Now, once I got the midpoints, I just go in there and I change the L2 value. So I'm going to go all the way to the top up here and clear. And then I'm going to type in our new function. Our new function this time is
3 over L.
3 and then you press
raise
arrow.
the up arrows to the power.
And then
Second L1.
No, I like your calculators more. It actually boosts it up, I think, right, for the little L2. For my calculator, it just has the caret there. So that's the same notation. It just looks a little different. Go ahead and press enter. These are the values we got. Terrible looking. And then everything in L3. Notice that I'm missing a couple L3 numbers down here, right?
Yeah.
I add, wait, hold on. 1, 2, 3, 4, 5, 6, 7.
Yeah, you add like 2.
Yeah.
Yeah, so I got to add this one and one more. Yeah, so you have to make sure you have the same number of entries to what you have on this one. Okay? So, question?
So I thought that you would cut the X or the L3s in half because since it's a median.
Ah, that's okay. I got you. So that's the part that used to get me as well. So I'm gonna zoom in here. So I don't know if you caught this question, right? The widths you would think would be cut in half, right? Because when you're looking at the midpoint, we're basically going to the middle of it, right? To get this height, yeah? But you're getting this entire rectangle right here. You see it? So I'm not cutting the base. I'm just going to the base to get the height of this rectangle. But I'm still looking for the whole volume, aren't I? And the whole volume has this whole base of 0.5. So that's why I don't change that width for this midpoint one. Okay? Now that I got that, why are we calling me? L4 is this. Now I should move my phone up to the front. I'm never back here. I used to be back here, but now I'm up there. All right.
Hi, people I'm recording.
We don't even have a
Why
scene
touch the
today.
soul? That's dirty.
I'd love to be in a ditch one day.
What?
Wait, you're trying to get the game.
Oh my gosh.
You always find a way.
He always finds a way.
I found a way.
Huh?
Wait, what?
Because she went like that to my foot. I'm like, oh, are you trying to get like stuff off?
Towards the end of class, we have to go to the
Have it rub off on you?
class, you got to go down to the career center.
I know that was me too.
Yeah, same with me. I don't know why. They just said go to the career center.
I don't know.
Okay, so let's finish this off. So L4 is going to be the multiplication of L2 and L3. Yes, Anita?
Mr. Naki.
Yes?
For L1, how do you just insert a thing without deleting?
How do I enter a thing without deleting all of it?
Yeah. Like how do you insert a number without deleting?
So you just go to the place you want to overwrite and you just type in a number. So for example, right here, if I didn't want 1.25, I could just type in the number 5 and then press enter and it will replace it.
But what if you don't want to replace at all?
What are you trying to do to the list?
I'm trying to take away negative 1.
Highlight it and press delete. Highlight the,
Oh,
yeah,
okay.
yeah. Okay, so let's get this up. Last one here is L4. L4 is in the equation again, so the equation for L4 is L2 times L3. We only know this, by the way, the reason why I'm multiplying it is because it's a rectangle, yeah? L2 is the height, L3 is the base. We multiply the height and the base together, and that gives us our area of a rectangle. Second quit to get out of there, and then we go ahead and just sum up. Oh, by the way, if you just press enter again, it just repeats what you had typed in before. But I don't suggest that because you should know where to find sum. So practice that first, and then once you do it one time, you can just press it and you'll. So did you guys get 23.97?
Yes.
Sir.
Malcolm, did you ever have increasing?
What? No.
Did you ever increase your grade? No?
No, why not?
I have a fear of someone just ripping it.
Yo, that's not true.
Oh
Okay.
my God, me
Okay,
too.
like you
Like
were-
this one this morning, she went yeet. And I was like, bro.
Okay. So are you okay with calculating areas using the calculator?
It was fun.
So if I give you homework, you'll be able to do it.
Yes,
We don't have a
yes,
calculator
yes.
at home.
Oh,
So
TI calculator on your phone.
get the TI app on your phone. They have a knockoff version of it on the iPhone.
It's actually really
Yeah,
If-
it's Math 84.
Yeah.
Calculate 84.
Calculate 84 sounds like it works.
What's it called?
It does. It works the
Calculate
same as the
84.
TI calculator.
So we'll do that. Here's the thing though. Before I let you go, this right here is a fancy way of adding up areas, which is not really calculus yet. Because if you think about it, we've only done like 8 rectangles. And before that we did 6 rectangles, right? Just like if you thought back before when we were calculating tangent lines, right? If I had like a point and another point right here, and it was part of a curve like this, right? You can calculate this secant line right here, right? The slope of that line by giving you 2 points. Eventually we made those 2 points get closer and closer and closer, and the distance between them were smaller and smaller, right? Until the point where it became 1, right? And if we do that the old school way, if we only have 1 point, it's undefined, right? But if we do the calculus way, which is to see what it approaches, it tells you the slope of that tangent line. Now, why am I bringing this up? Check this out. Don't write this down, but just check this out. This is the equation I showed you earlier. Don't look at all of that, just look at this part right here. I want you to focus on this part of it right here. This is what we've been doing on our calculator, right? We've been calculating rectangles areas, and then we've been summing them up, right? Except the number on top was the letter n, and that n told you of how many rectangles you had. If I increase the number of rectangles, the approximation gets more and more accurate, doesn't it? You can kind of picture it, yeah? In fact, if you increase it so much, though, it ends up just equaling to it. And that's the part I want to show you. You ready? So don't worry about writing this down, but check this out. Let me give you my favorite app. So much better than. All right. Check this out. Check this out. Give me a second. Let me log in first. Because I have this equation saved. Not that one. That's a different one. Just ignore that one. So let's look at a RRAM. Yeah, let's look at an RRAM. So this is the part that's kind of neat. So let's say I had a function that we were looking at, which is the first function we were dealing with was 9 minus x squared, right? And we were doing this from 0 to, I think it was 3. And how many rectangles did we have? 6 rectangles. There you go. So here's that right there. And you'll say, knock me, I only count 5. Where's the 6th rectangle? The 6th rectangle has a R, right? So it's on the right side, so it's it's a height of 0. It's on the height of this rectangle is at 0 because it's on the right side. So here's the part I wanted you to see, right? If I only have 6 rectangles, I'm missing out here, 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 and here, right? But watch what happens as I start increasing the number of rectangles. So I go to 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 is the max I can do on this one, but notice what's happening.
The space, the empty space gets smaller and smaller.
The empty space is getting smaller and smaller, and the area is getting closer and closer to the actual area, isn't it? Now, they give us the estimation right here, by the way, so if you look closely, this looks crazy, this summation, right? But it's not that bad. The F of stuff was K, right, X sub K. They're doing a formula to calculate this. So this is the height of it. So all these heights are calculated by this equation right here. The widths are calculated by this formula I gave you earlier, b minus a over n, to give you the widths. Notice they're all the same widths. Those widths are calculated with that formula. This is going to multiply them together like they did on your calculator, and then it's going to sum them all up, and that's the area that they're calculating. And that's what your calculator is doing, right? But I just wanted you to visually see it. That's what's happening if you were to get this more and more. Now, check this out. Let me see if I can find the right one. I put this somewhere, and I don't remember where. Here it is. I do remember where. This is the part I find really neat. This one can go more than just that amount. So let's do this real quick. 9 minus x squared, yes? And let's go ahead and do a this is the right endpoint, and let's do the right approximation. So there's the right side, yeah? So we stopped at 20 earlier, right? Which looked like this, yeah? Yeah, watch what happens.
Bruh, at that point, there's no empty space.
Well, technically.
That's so dope.
Jesus.
Neat, yeah? Now check this out. Check this out. You ready? What if I didn't go to 100? What if I go to 1,000?
Whoa. It's filled.
Looks filled, huh?
No, zoom in.
There's a little bit. Oh my god.
That's very, very tiny, right?
Lame.
What if I go to 10,000?
There's
More.
Everything,
Never
everything is
achievable,
pixels.
though.
Everything is
So at this
pixels,
point,
yeah.
it's just, you know.
Now,
same amount.
More zeros.
this is the part that's neat, though.
Imagine
It looks almost completely filled, right?
Yeah.
Now, if you get that idea, right, what if we go to infinity? Now, we don't know how to calculate infinity. That's fair, right? I have no idea what math's to do with infinity. But as it approaches infinity, would you agree that the area of this approximation approaches what the area is?
Yeah.
So if we can calculate the limit of that as it approaches infinity, we can calculate this area. And if you do that,
Could you say that at one point, it's gonna just be fully covered so we will get the actual area?
yes, and that's this part right here. If you do this for infinite rectangles, you will get the area underneath the curve. And the symbol that we use, instead of writing this all down, we write it and call it the integral. That's what the integral is. The integral. The integral is
Interruption.
that thing that
I
helps
want
you
to give a
calculate.
quick and huge shout out to our girls wrestling team,
All right.
specifically